the XCVM, cross-chain virtual machine. This lies at the heart of XCM. It's what helps give meaning to its messages. Now, there's a tendency. It's easy to think that the XCVM is everything with message meaning, that you can't, if you want to express something that isn't obviously already has an example of being expressed, that you would need to extend the XCVM. Now, I want to emphasize this isn't always the case, and that oftentimes you can give new meaning to pre-existing instructions in the XCVM by clever use of locations. But that aside, it's still very important to understand what instructions you have to play with to begin with. So, the XCVM. So an XCM message is basically a program of the XCVM, right? Contains a bunch of XCVM instructions. The XCVM is a register machine, so it has some state, and these are the registers. They're not your typical CPU registers of like 64 bits or anything like this. They're very sophisticated registers, but you can still think of them as registers, just very, very high level registers. There is one register called the holding register, another one called the origin register. There are several others. I think there's about 9 or 10 in total. So the origin register has an optional location, and not super surprisingly, this is the origin of the current executing message or program. In the context of XCVM, of course, we call messages programs, but they're actually the same thing. They're both just a sequence of instructions. The origin register, indeed all registers, except I think there's one exception, all registers can be mutated. There may be reasons for the registers to change over time. There is one that doesn't mutate. That's the original origin register. That's read-only. That's the origin that the message came in with. But the origin register, for example, can change. You do quite interesting things with it because it can change. Another register that's very often used is the holding register. The holding register is for stores assets. There you can think of them as being unspent assets. It's actually just a set of assets in the XCM sense of the word. There is no specific account ID associated with the holding register. It's a register. It's not an account. There is no specific pallet associated with the holding register. It's a register, right? It's not an on-chain, long-lived piece of state. It's a piece of state in the virtual machine alone. When the program stops executing, when the message is done, whatever's in the holding register just vanishes, right? So that's the first thing to be very clear on. No account ID, no pallet. Now you might remove something. A pallet might track a removal of an asset from an account ID before it is placed in the holding register, and then the asset sort of sits unspent in the holding register. And then similarly, you might take an asset from the holding register and put it into an account, in which point a pallet will alter its on-chain state according to some account ID, and add that asset to it. But while an asset is in the holding register, it is not being tracked on-chain in any way at all. This is a purely ephemeral thing. The holding register. It exists only as long as the program executes. Yeah? Clear on that. All right, so we have some instructions. Instructions might change a register. They might read a register. They usually do. They usually read at least the origin register. They might change the state of the underlying on-chain state, you know, make some change in some palettes state, or they might do both. Yeah. There's a few different kinds of instructions. They're not really categorically different things, but it makes sense to sort of group them a little bit, just to help you understand the sorts of things that instructions might do. So they might be telling the machine to do something. You might be it might be an instruction that indicates something has happened, which kind of is telling the machine to do something still. It has an effect, presumably, but the idea is that it comes from some trusted location that is telling us something has happened, as opposed to a user that is instructing something to happen. Subtle difference. Might be information, again, coming from perhaps some trusted location or something. Or it might be a system notification. They're a bit blurry, but you can usually, they can be quite helpful just to sort of understand the sort of use cases for instructions. But don't worry if it all sounds very blurry. There are, as I say, there are no categorical differences between these. Right, let's have a look at an example. Withdraw asset. So this would be an example of a regular command instruction, right? A user wants to do something. So it's used to get assets, take them out of an account. So by this, what we mean is some pallet on chain is going to change its state, right? It's going to, maybe it's got an account ID to balance or something map. And it's going to take, it's going to remove something, it's going to reduce a balance, or it's going to annul an NFT entry for a particular account, and equal and opposite reaction, right? It's going to put something in the holding register as the counterpart action. That's what withdraw asset does. Now you say, well, how does it know which account ID to take the asset from? We know it's going into the holding register, but how do we know where it's coming from? Well, if you remember, we talked in the last lecture about sovereign accounts. There's your answer. The asset is withdrawn from the sovereign account of the current origin. So it looks at the current origin, it turns it into an account ID, and then it says, and then it reduces that account ID's asset by this, in whatever way it makes sense for the chain to do. It's up to the chain to work out how it makes sense. And then introduces these assets into the holding register. That assets there can be a wild card, right? So it could be that it's all of your all the ETH, all the DOT, all the USDT, right? It could be a wild card in that regard. It's usually not. It's usually something specific, but it can be. Again, it's up to the chain to make sense of it. There are lots of programs that won't make sense to lots of XCVM instances. For example, if you had a wildcard here that just said all assets, the chain might not support evaluating that, because it might be that attempting to withdraw all assets is just too heavy of an operation for the chain to consider doing, because it would have to go through like all of its pallets that might hold assets, then it would have to go through all of the asset IDs that each of those pallets supports, so it would have to check if there's any balances or NFTs or anything held by the account ID, and that's just like way too much effort. So it might just say, no, not supporting that error, right? And it's up to the XCM sender to understand the subset of the XCM language that its receiver will be able to interpret. Now, if it's a substrate chain and it's configured regularly, then there will be a particular set of things that you can expect it to understand. But this is left as sort of a higher level, something to be solved on a higher level. Like XCM doesn't explicitly say this subset of the language must be supported. Okay, so that's withdraw asset. Relatively simple. Uses the concept of a sovereign account. Technically, withdraw asset itself doesn't care about sovereign accounts. All current implementations of withdraw asset use the concept of a sovereign account, but technically, if a chain stored assets under locations rather than account IDs, it wouldn't need to switch the origin location into an account ID before trying to find and subtract a balance or an NFT entry, right? It's just that at the moment, all the chains that support XCM store assets under account IDs, and therefore we need a way of converting the XCM origin into an account ID, and that's what the sovereign account comes in. Okay, let's look at another example. Receive teleported asset. Now, receive teleported asset is still an instruction, but this is what we would call a trusted indication. Why? Well, because it's based on a trust relationship. Teleporting an asset implies that on some other trusted chain or consensus system, a particular asset was destroyed with the intention of creating magically a version of itself on some destination chain. And this is what we receive, the instruction we get on the destination chain saying, hey, I'm the source chain and I've just destroyed this asset. You should mint an asset equal on your chain. So if you're looking at it in terms of just what it does is it just magically creates an asset out of nothing. Yeah, but the reason it does that is because it trusts that the origin chain destroyed an asset forever. Yeah, so it's kind of like if you're on, I don't know, if you're on the relay chain and you want to transfer some dot over onto the asset hub chain, right? This is an example of a teleportable pairing because they both trust each other. They're both under control of the same governance system. They're happy that they will be faithful to each other, right? And what that means is that if the relay chain says, hey, asset hub, I destroyed 100 dot, you need to mint 100 dot, then the asset hub will trust that the relay chain did actually really destroy 100 dot, and it's not just trying to give itself 100 more dot on the asset hub, right? Similarly, if the asset hub says a message back again, hey, I destroyed 100 dot, you should mint 100 dot, the relay chain trusts the asset hub. There are bounds to this trust. For example, the relay chain will never create more dot than it has already sent out to the asset hub. So if it's in total in the past, it's sent 1 million dot to the asset hub, and I don't know, 900,000 dot has come back from the asset hub, and an asset hub says, right, mint me 100,001 dot, and it will say, no, I sent you 1 million, and this would mean that I've got 1,000,001 back, and I know you're not allowed to issue dot, therefore this is an invalid instruction, right? So there are limits to this, but by and large, teleports don't require, they're bipartisan, they're bilateral. Right, there isn't a third party involved with teleports. And as I say, this instruction is basically what the receiving chain gets told by the sending chain. And it implies a trust that the sender has destroyed exactly these assets. Yep. Clear? Okay. Another example, query response. So this is I told you before, XCM isn't symmetric, right? It's an asymmetric system, doesn't have a return path. That doesn't mean that you can't have instructions within an asymmetric system that are there primarily for information transfer that might perhaps be invited. Yeah, it's just that it doesn't happen on the level of. It's not that you can always assume that you will get a return path back, but if there is an underlying return path, you might use query response to use that, right? It's one of the instructions you might use. It's basically information. But it's information that has been invited back. So there is an identifier for a query, right? So it's a classic, query response. Sender says, hey, what's the balance of this account ID? Receiver gets that and then constructs a query response message with the response. It is this balance. The query ID, so it knows which query it's replying to. There's a few extra bits. The querier, so it knows who it received the query from. And it fires off the query response back to where it thinks the sender is. Back to the sender from its point of view. Now we have to do some clever things with weight. And we include the querier so it's clear in case there's some crazy send spoofing going on. But that's rather advanced for now. I'm not going to go into that yet. So another example though. Yep.
Thank you. Yes. Thank you. The query in this context is the withdraw assets, for example, or the receive teleport.
No, they don't initiate a query response. There are specific query instructions. I haven't given any of those yet.
We'll get to that.
Maybe it's something to add before in future lectures. But yeah, they exist. One of them is query balance. So you can say, right, what assets do I have? And it will give you, it will make a message with just this instruction in it and fire it back to you.
Okay, but I imagine that this is from the palette that we're going to be looking at later, right?
Correct.
So there would be like also a corresponding query ID, all that terminology.
Yeah.
Okay.
Yeah. All right, let's have a look at the basic operation of the XCVM. So as I say, you might have a program that looks like this: withdraw asset, buy execution, deposit asset. Now the XCVM assumes for now that this program is the receiving chain has decided that this program is worth executing. There is a specific system that it uses to decide which messages are worth executing. I'm not going to go into that yet, but it does exist. For now, we just assume it's already decided it's worth executing and it's now executing it. So we've got the two registers we've covered, origin and holding. The program is these three instructions. So it's fetching the first instruction, right? Usual fetch execute cycle. In this case, withdraw asset. So it needs to find out what assets origin has. once it's got those assets and it's assumed, knows what the assets are that it's putting in the holding, and it's decided that the instruction is indeed valid, then it puts the assets in holding. Holding now mutates to have these assets in it, and we will assume for now that whatever it was that was getting the assets at this stage actually removed it, altered on-chain state to remove those assets from state. Yeah. So the assets have been removed from the on-chain state, which is presumably in some pallet somewhere, or even set of pallets, and it's gone into virtual machine state, specifically the holding register. Next, we fetch the by execution instruction and execute it. By execution basically does a trade. It removes some of the assets from the holding register in exchange for essentially in exchange for nothing at this point. At this point in exchange for nothing. But notionally in exchange for execution weight, for allowing instructions to be executed. Now in reality, this by execution instruction only removes assets from the holding register, and its existence has already been checked way back before we start executing the program, when we're deciding whether it's worth executing, right? The step that I just told you we're skipping for now because we've already decided. So actually at this point, all it really does is burn from the holding register, burn some assets. Which is why it's so short. We fetch it and we execute it, which means we remove some assets from holding, and then that's it. So finally, we fetch the deposit asset instruction. Now what this is going to do is it's going to, well, you should be able to figure it out for yourself, really. It's going to remove some assets from the holding register, and it's going to work out what working out where the assets should go, and put them into an account. Now, actually, in this case, this is wrong. There's Keith around. Yeah, this is wrong. We don't care what the origin is. We actually provide the location for where the assets are going to be deposited. Yeah, we don't automatically deposit the assets in the origin account in the same way that when we're withdrawing, we do automatically withdraw from the origin account, because it's the only account that we have permission to withdraw from, right? But when we're depositing, you don't need permission to deposit into someone else's account. That's kind of the whole point of depositing, right? It's to allow you to transfer into someone else's account. So we don't care what the origin is. The origin doesn't get checked. Deposit asset actually includes an argument that says where you want the assets to be deposited. Now, that argument isn't an account ID. It's rather it's a location, and therefore you'll still use this sovereign account conversion to convert the location into an account ID, usually, as long as whatever is actually enacting the deposit cares about account IDs rather than about locations. In theory, someone could come up with a pallet that cared about locations rather than account IDs, and actually stored assets keyed by a location rather than account ID, in which case you wouldn't bother using the sovereign account. But in all of the implementations of this that I know, it's all account ID based, and therefore you need to be able to convert a location into an account ID in order to deposit the asset on chain. All right, what else do we have? We have two interesting registers for managing exceptional circumstances. The error handler register and the appendix register. Now, if you're familiar with try, catch, finally, then you'll be familiar with this pattern. Essentially, the error handler is the bit that goes in the catch branch. It's like if something unexpected happens, if an instruction can't do what it's meant to do, then rather than continuing, it actually replaces the current program with whatever program is in the error handler register. So the error handler register is actually just a program. Yep. The appendix register is also a program. What happens with the appendix register is that as soon as whatever program has finished executing, that program is replaced with whatever is in the appendix register, and the appendix register is cleared. Yeah. So it's kind of like the thing that executes after whatever is finished executing. Notably, this isn't cleared if the error handler replaces the main program because of an error. So this is like the finally part of the try-catch finally triad, right? And using these two, you can write programs that can basically handle errors, right? And you can do things like send query responses back if there is an error, and do all of that sort of sophisticated error handling code. Good. These registers are settable with just instructions: set error handler, set appendix. Right? They take one parameter, which is the code, the program that you want to be in the register. And interestingly, you can't nest them exactly. I mean, you can nest them, but there's only ever one appendix register and one error handler register. But the appendix, the code in the appendix can also include a set appendix instruction, right? There's no problem with that. So you can, in theory, just sort of create appendices with appendices with appendices with appendices. Okay, now let's move on. Re-anchoring. When you're executing a program in the XCVM, you come across an interesting problem. The problem can be formulated as saying that when you send a message to another location, and it gets executed at the other location, and the message itself contains a location, then because locations are relative, the meaning of that location will change as it goes from the send place to the source location to the destination location. Yeah? For example, suppose the location is here. In Unix directory path terms, it would be a single dot. Yeah? Here, current directory. Yeah? Current place. Well, here, if you're sending a message from, I don't know, Asset Hub to Bridge Hub, here on Asset Hub means Asset Hub, whereas here on Bridge Hub means Bridge Hub. If the message contains here in it, then it means something different on Asset Hub than it does on Bridge Hub, and we have a bit of an issue. This issue is very, in general, we say a message should be sent such that its interpretation at the destination is correct. You have this rule in XCM. Messages are constructed so that at the destination, when they arrive at the destination, their interpretation is correct. So they might not be correct when you're composing the message at the source, if it's got any of these locations in. Assets are identified by locations. And they become a bit of a problem because we have assets, like maybe this USDT asset, which exists here under Palette Assets, under Asset Hub. And we want to send this asset over. Well, we need the assets to be, we need to identify it correctly at the point that we're sending it. But when it eventually gets received, it's going to be a different thing. It's going to be, I mean, it will be identified here as Palette Assets /USDT, Well, if we were to send that asset over here, it would be identified as Bridge Hub's pallet assets USDT. Yeah. Whereas actually what we mean is ... asset hub pallet assets USDT. Now, what we do in this case is for the instructions that incidentally contain a location, in particular the asset instructions, things like withdraw asset, is we apply something called message re-anchoring on them. So in this case, if we're sending USDT over, it's pallet assets USDT, okay? Simple enough. As it happens, USDT is 1984. Wow, the serendipitous. And if we are sending a message to Bridge Hub sending this asset to Bridge Hub, then we want it to be considered as ... parachain 1000 / pallet assets USDT. Yeah. Which means we go through this step called re-anchoring. Re-anchoring basically says, well, the message is written from the point of view of this location, but it's being sent to this location. Therefore, please re-anchor or translate all of the locations in the message so that it's referring to the same thing, but just from this new position. Now, if you're just manually making the messages, re-anchoring isn't important because you will already have the message in the destination correct form. But it makes a lot of difference when you are programmatically making a message and you need to programmatically kind of make a new message. For example, if you're forwarding a piece of a message onto a new destination, you're going to need to have to do this re-anchoring faff, because the original message composer won't necessarily know where the message is going to be, or won't necessarily have composed this sub portion of the message with this re-anchoring in mind. I'll give specific examples of this later in case it's a bit opaque at the moment, but just beware that a facility exists in the XCM code base that allows you to translate a location that's relative from one place into a location that's referring to the same thing relative to another place. Okay? That functionality exists and it's really easy to use. All right, next, cross-consensus transfers. So this is dealing from when we have assets that exist in one consensus system and we want to somehow we want to transfer them, whatever that means, because it's a bit of a vague thing. What does it mean to transfer, Bitcoin into Polkadot? What is that, These things are self-sovereign. There is not necessarily a very obvious interpretation always for cross-consensus transfers. But let's start with a simple example, asset teleportation. So we've already sort of covered this a little bit earlier. It's where we have two chains, a bilateral arrangement between the chains. We have some asset on one chain, and we want to remove the asset from that chain and sort of teleport it over to this chain, create the asset on the other chain. Yeah, think like Star Trek teleporter. Yeah? Now, if there's a trust relationship, like there is, for example, between Bridge Hub and Asset Hub, teleportation works because, as I say, these two, as I mentioned before, Asset Hub trusts that Bridge Hub will indeed have destroyed the asset before Asset Hub mints it itself. And of course, this all relies completely on Polkadot's shared security umbrella, which basically says Bridge Hub cannot be reverted without Asset Hub being reverted as well. Yeah, and this is what is a crucial difference between Polkadot's shared security, Polkadot being a sharded system, versus something like any one of the Ethereum to other network bridges or Cosmos or whatever, where the security umbrellas are different, and one could potentially be reverted without the other one being reverted. So if we're, for example, teleporting, if we are attempting to transfer assets from Polkadot to Kusama, there is no basis of trust, right? Polkadot has a different governance system to Kusama, has a different consensus system to Kusama. There's no reason that Polkadot could reasonably accept DOT from Kusama and believe that it had been burnt on Kusama. Maybe it's under a governance attack, maybe it's on a fork that's going to get reverted. You just don't know. And so teleportation would not be a viable mechanism between Polkadot and Kusama, or indeed any bridged networks. Rather, we have to rely in these cases on reserve asset transfers. Yeah. Our reserve asset transfers assert that there is a single trusted third-party chain that these two chains can agree on as being a sort of issuing chain, right? Usually, this third-party chain is going to be the chain that can create these tokens anyway, so there's no additional trust involved, right? So, for example, if we're talking about DOT, this reserve chain would be maybe the asset hub or the relay chain, right? Because it's controlled by governance, and governance can just create new DOT anyway. So it's not like you're trusting anything extra when you use this as a sort of intermediary between the source and destination of the transfer. But you wouldn't necessarily use Asset Hub to transfer, for example, Akala tokens, right? You would probably use Akala as the reserve chain for that, because it's Akala and only Akala that can create the Akala tokens. Now, in reality, you can probably use Asset Hub as well, because if you're on Polkadot, you probably trust Polkadot governance, and therefore you probably trust Asset Hub not to just arbitrarily mint more of these tokens. But that's sort of a decision. And it's a little bit also what's already happened. You're going to want to use the reserve that everyone else is using, whether that's specifically that chain that is the issuing chain or Asset Hub is a different thing. USDT, well, it's issued onto Asset Hub, and therefore you would use a reserve that is Asset Hub. As I said before, if chain A and B are under the same trust relationship, if they trust each other totally, perhaps because they've been launched by the same team or they have the same governance, then it's reasonable to ditch the reserve-based transfer and just teleport directly. When you have a reserve-based transfer, chain R, the way it specifically works is that chain R has sovereign accounts for both chains A and B. And the sovereign account of chain A on chain R holds all of A's assets, USDT or whatever it is, and the sovereign account for chain B on chain R holds all of B's assets. And when chain A wants to send assets to chain B, what it actually does is it sends a message to chain R, and it says, right, take some assets out of my account, please, and put them into B's sovereign account on your chain, right? So far, so good, yeah? So A's got fewer assets on R, B has now got more assets on R, but also tell B that you did this. And by the way, also tell them give him this information, some extra information, a message. Why? Well, because firstly, it saves A having to send 2 messages. Secondly, it saves ordering possibilities. You don't want a message to arrive on B telling B what to do with the new assets before B has had chance to ascertain that it has received them into its sovereign account on R. Yeah. And C, B has no reason to trust A. We've already established that. B, there is no trust relationship between B and A. B trusts R, sure, but it doesn't trust A. And therefore, the only place that it could possibly accept a message from, in this case, would be R, to tell it that indeed it has received assets. Because R is the only place that it trusts regarding the receipt of these assets. Right? It's R that it has a sovereign account on, not A. Now this introduces a bit of an issue. So let's review. A sends a message to R. It says, remove assets from my account, please, and transfer them into B's account. Right? So it's a simple asset transfer. As a consequence of this, it asks R to please send a notifier to B. This will be a trusted notifier that says, because B trusts R on the point of this asset, B trusts R, that says, hey, A sent you some assets, this amount. They're in your account now. So it's like cool. It's like a statement from the bank saying you've received, you've received some money from whoever. And by the way, A tells me, I'm giving you a message from A about what to do about this. Because usually you don't just want to transfer something to B. You actually want to do something with the assets on B, like issue a derivative on B, like issue some placeholder asset on B that means you own a portion of these reserve assets. Usually it's like a one-to-one thing, right? So for example, if it's dot, then the dot on A isn't like, it's not real dot, right? It's sort of dot, but it's a derivative. It's a one-to-one derivative with dot held by A on R. Yeah? Dot owned and controlled by A on R. Yeah? And so when you transfer that quote unquote dot, it's not real dot, you can't stake with it. It's not like actual bona fide dot. It's still a derivative. It's just say again? What? Rapid? Oh, wrapped. Kind of. Similar sort of idea. Yeah. Without the bridge. Normally when you wrap an asset, there's a sort of questionable trust relationship. In this case, A trusts R anyway, but essentially, yes, the dot on A is kind of wrapped dot that is on R. Sure. So when you're moving wrapped dot from A to B, you're moving the underlying asset, the real dot, from A's sovereign account to B's sovereign account on the dot holding chain, like the real dot chain. Well, you want to tell B to like actually make that new wrapped dot, yeah? Now that it's got some more dot in its sovereign account on R, you want to tell it to actually create the dot. One would also presume A burns its wrapped dot for its own bookkeeping purposes. In principle, it doesn't have to. It's a sovereign chain. There's no reason why it needs to. But if it didn't do that, then whoever's dot it is would just keep sending it, and they would eventually just drain the reserve account of A. So we presume that A does do this as a self-preservation thing more than anything else. So okay, the wrap dots arrive. Now, that message has been forwarded by R. Now, B might trust R regarding dot. It doesn't trust R to represent all of A's interests. Right? This is a crucial point to understand. Therefore, when this message comes in, the origin is R. But similarly, R can't leave itself as the origin of any message that A has sent, because A could just put in random, random instructions that like drained assets held by R on B, like controlled by R on B. So R doesn't trust A, when it's speaking to B, and B doesn't trust R for anything that it might be relaying from A. And therefore, the only way that we can possibly get around this is when R is forwarding the message from A into B, for it to say, this is no longer coming from me, clear the origin, and I know that you won't trust that, I could tell you that this message is coming from A, but I know that you can't trust me on that, therefore, I'm just going to leave the origin as empty. And the origin, it's like there is no origin, which means any of the stuff that would normally require an origin, like withdraw asset, just can't work. Yeah. But the assets are in the holding register, which means we can utilize those assets. We can do stuff with the assets. We just can't do anything that would require a trusted origin. Yeah. Now, the way around this is to use something like spree and accords that would require R to honorably forward A's message. Like that logic would no longer be in R's main piece of logic. It would be in a sort of sidecar bit that would be that R would have no control over. This is how we would solve this problem properly, but we don't have spree and accords for the moment. It will be a lot easier to deliver once we have core jam. But for now, we have this clear origin thing going on. And this is what I'm going to come to next. So, okay, this is just going over Kusama. So, yeah, Polkadot says move the assets into Kusama's sovereign account. And then it tells Kusama, hey, you've received assets in your account. You mint the assets, please. And then do this with them after clearing the origin. Okay, so withdraw asset instruction. There it is, withdraw asset. There's some assets that it takes as a parameter. By execution, this is what we're offering for our execution. This is the amount of weight that we want to buy. Deposit asset. This is the assets that we want to take from out of the holding register. This is where we want to put them. Putting it together. So we withdraw the asset, we buy the execution. If we're lazy, we set the weight limit to unlimited. And what that does is it just, when it arrives at the destination, the actual weight is measured properly, and then it replaces the weight limit with the actual weight. But if you're doing it properly, you will limit the amount of weight to something sensible so that it can't just decide that you've got like infinite weight and then take all of your money. Similarly, the fees, we could just put everything, like everything in the holding register. Unlimited weight would just basically say, take everything you need from what's been transferred to pay for the fees, and anything left, do whatever else with deposit asset in this case. Yeah, but if you're doing it properly, you'll when you're sending the message, you'll first look at your destination, work out what the fees are, weigh the message in terms of the destination, limit it there, put the fees properly here, and right. It kind of depends on how much you sort of trust the destination chain. If you trust that it's going to be sensible, and you don't really mind too much, if you're going to pay a bit more fees than you expect, then you can probably be quite laissez-faire in this part. XCM allows you the possibility of both in any case. And then finally, the deposit asset just allows us to say, in this case, all of the assets into some particular account ID. Yes, so we might have purchased too much weight, in which case we can do this refund surplus instruction. And what that does is it converts that extra weight back into assets, and then we can deposit those assets. Maybe, for example, in the sender account. because maybe we sent what we wanted to, we got some left over, so we did everything that's left over we put back in our account on the destination chain still, but hey, we control it, so we can presumably get it back again at some point. Okay, let's look at reserve asset transfer. So we're going to come back to that thing I was talking about just a minute or two back. Right, so when we initiate a reserve asset transfer, and for what it's worth, this is real code, so XCM is just a vec of instructions, very simple. So we withdraw the asset, okay, great. Initiate the reserve withdraw, right? What this does is it says, destroy these assets, send a message to the reserve location asking for the assets to be moved from this chain's sovereign account to a destination sovereign account, and then tell it to send a notification to the final chain, the destination chain, with this message in, so it should execute this specific message. Yeah. That message is what we want it to do with the funds. Now, the message that gets received in the reserve chain, go on.
What happens if I send the message, but like just part of it, just withdraw something, but not?
All right, I'll come to that later. Let me finish this first. All right, the message that is received in the reserve chain is a withdraw asset with the re-anchored asset, right? Because it's not us that has composed this message, right? That we, the dev, have not composed this message. This message has been composed by whoever implemented the XCVM, and specifically implemented the initiate reserve withdraw instruction on the XCVM. So the message that gets sent to the reserve, the third party, withdraw asset, that's easy enough with a re-anchored asset. So it's the asset that, it's not the asset that we are calling the name that we're calling it by, because that's relative to us on the sending chain. It's that asset, but re-anchored to the point of view of the reserve chain. Yeah. Then there's a this isn't really needed here. And then there are instructions to tell the okay, right. No. This is a reserve withdraw, not a reserve transfer. So there are two types of instruction here. One of them is withdraw, one of them is transfer. But all withdraw doesn't transfer it on to a destination. All it does is tell it to withdraw from the sovereign account and just sort of leave it hanging there in the holding register, okay? So we're now just dealing only with the intermediary, not with the final, in the previous example, the final destination. So what we're saying is, suppose we have dots held in reserve on, I don't know, the relay chain, then we're sending it to the relay chain saying withdraw some dots from the sender's sovereign account and then do something with them. But crucially, we have some custom instructions about what to do with the dots. For example, it might be stick them in my account or start staking or something like this. But this message is being sent by, say, Asset Hub to the relay chain, yeah? And so these instructions are coming from the user, yeah? It's whatever the user wants to do with the dot, the real dot that exists on the relay chain. Probably not the asset because that's teleportation, but like, I don't know, the Akala chain, right? So this message is coming from the Akala chain. These instructions are coming from decided by a user on the Akala chain. And therefore, it is crucial that we do the clear origin before executing the instructions. Why is it crucial? it is crucial because the message origin is the Akala chain, yet the instructions are set by a user, right? A randomer, a person that owns some dot or holds some dot on the Akala chain and wants to now use that dot on the relay chain. If we allowed them to do anything, well, we do allow them to do anything. If we didn't clear the origin, these instructions would execute with the Akala chain's origin, and therefore they could withdraw all of the other stuff that the Akala chain holds on the relay chain. Yeah? Which obviously we can't allow. So before we go on to execute these, before we tell the relay chain to execute these instructions, we first say, this is no longer the Akala chain speaking. This is some other random guy. And furthermore, you can't trust me, the Akala chain, to tell you who it is, because then I could just fake anyone, right? So therefore, the only thing that makes sense is to clear the origin, just leave it unset. So that's why origin is an option of a location, not just a location. The origin is allowed to be none, and that's what this instruction does. It says set the origin to none, right? There is no way that what I'm telling you to do, you can trust it to be coming from its real initiator. Therefore, and it's definitely not coming from me. Therefore, just pretend they're not coming from anyone, right? And the only thing these instructions can work with is the asset, the contents of the registers as they stand, i.e. after the withdrawal. Yeah, go on.
Yeah, so my question is on the clear origin, and also I wanted to ask on the descent origin in the XCM context. As I said, clear origin puts the origin to none. It means even in the XCM context, the origin is set to none. But what if the destination chains wants to know the account origin, not the chain origin, but in terms of the account origin, the account ID, and works because at the moment before he will specify the destination, the beneficiary address, but also we want to get the origin address from and work with them both, because we are getting those from XM context. But if clear origin like set it to none, but can we work with descent origin to kind of overcome that?
Sure. So you clear the origin, but the user can set these instructions to be whatever they want. Now they can't set it to be like set origin, because obviously that would allow origin spoofing. But if they're working with the asset specifically, if they want to deposit the asset somewhere, then they can set what the beneficiary is. And this is how they let them know that it's this account ID to credit for the asset, please.
Yeah, what if we, like in the destination chain, we also want to get the origin account ID? Can we use descent origin for that?
Well, it's not, you can't like get the origin, you have to use it for something. And whatever you're using it for example, if you're using it for a deposit, making a deposit of these assets, then you would just include it as the parameter.
The origin which sent those instructions.
So yeah?
I'm saying the account ID which send those instructions, we can include it in the instructions parameters and get it to the destination chain.
Indeed, these instructions are verbatim. They're not changed. Other than no, not even other than re-anchoring. They're just not changed. So these are supplied by the user at the point of message initiation, way back on the sender. And they're not changed. They just arrive here, inserted into this message.
Yes. But what if we also want to get okay, for example, Alice is constructing those messages, right? Composing those instructions. And the beneficiary is Bob, and the destination chain, maybe it's chain B, right?
Yeah.
In chain B, we want, of course, we have the Bob address, but also we want to get the Alice address.
Yep. So you can put the Alice address in here.
Oh, okay. Thank you.
Yeah. They're instructions. They take parameters.
Thank you.
That's where the Alice address belongs. Yeah.
I think maybe to answer your question, like it's maybe like the re-anchoring is what would map to the original asset and account, if I'm not mistaken. And my question is, if the clear origin is kind of like very, very important and very, very crucial and needed, is it like kind of, I'm not sure in what context we are looking at it now, like maybe in frame, the corresponding palette kind of like takes care of it, or is there a case to not clear the origin? Like if the clear origin is crucial and is always needed, is it somehow, or can it be somehow embedded in a way that would always happen?
It's not always needed. It's needed in this specific pattern where you are relaying instructions for someone you don't trust.
Okay, so it's only in the non-trust case.
Yeah.
Okay.
So in this case, there are three economic actors involved. There is the original user, who is deciding what it is that they want to do with their portion of the assets. There is the sending chain, which is holding the assets on that user's behalf. And then there is the reserve chain, reserve location, which is where the assets actually live. Now, none of these three things trust each other. Yeah. The user doesn't hold assets directly on the reserve chain. If they did, then it wouldn't matter. Right? They're holding the assets via via this source chain's account, a sovereign account on the reserve chain, and so they are. I mean, okay, in principle, you could get away without a clear origin if you checked these instructions and you made sure that they weren't doing anything you didn't like. But checking these instructions is really hard because XCM can do all sorts of stuff. Yeah. And so the fail-safe, absolutely secure way is to just clear the origin. Then the instructions cannot possibly harm you as the initiator of a message.
In that case, would it make sense that the palette would provide like mechanisms to do like trusted one and untrusted one? So it will be like, you know, the untrusted would always clear the origin and the trusted wouldn't?
I mean, it's up to the sending chain to put this in or not, as they choose. After all, it is their implementation of the initiate, reserve, withdraw that constructs this message.
Yeah. I'm just thinking
so
of, like,
they can implement that as they want.
I'm just thinking of abstractions and like making things more safe.
But in general, I think there's very limited scope for these instructions to do anything with the reserve chains. Sorry, not with the reserve chains, with the sending chain's privileges that the sending chain would be happy with a user doing. I mean, I can't think of what a sending chain would want to allow a user to do that it wouldn't also be able to do with the origin cleared.
Yeah, no, I'm just saying you described like the case that the clear origin wouldn't be wanted, like in the trusted case, right? And then there's a case that it's absolutely crucial, which is the untrusted case, like the three parties.
Yeah, so you probably wouldn't want to do. I mean, if it's a trusted case, you would just send withdraw asset yourself.
Yeah,
like you would just make this message. You wouldn't bother. You just have a special palette, and you know a palette that like created a message that sent the withdraw asset.
Yeah,
like there would be no need to use XCM for that.
Okay. So.
I mean, to use XCM's initiate, reserve, withdraw.
Okay.
One other possibility that could be done here, and this isn't something that we've looked into because mostly I think because the instruction didn't exist when this pattern was being designed. We actually have another instruction called descend origin. What descend origin does is it says, it basically says, consider only me as being this interior location, right? So it's kind of like, stop thinking of me as assets hub parachain, and instead think of me as account ID Gav on assets hub parachain. Why is this safe? Why is descend origin safe? Well, because an interior location is necessarily controllable by its parent. Yeah, because we've decided this is just part of what an interior location is. Its state is determined by its parent. Therefore, it's reasonable for the parent is necessarily in control of it, so to speak. Now, it might be that, like Polkadot and a parachain being in control of it is that there's a lot of latitude for sovereignty. But in principle, Polkadot grants the sovereignty to the parachain. If Polkadot governance decided, it can change a parachain's head, and indeed does do it quite regularly to rescue parachains that have bricked themselves. Yeah. So governance can jump in and do make exceptional alterations to the state of an interior location. Yeah. And essentially, an interior location state is decided by, and its state transition is decided by its parent, all the way up to the top. So in principle, if you are at any particular origin, if you are allowed to descend into an origin and just pretend to be that origin. That's not spoofing, that's just allowed by definition. Yeah. But at the moment, we take a more conservative approach and clear the origin, rather than descend into a more harmless origin, or an origin that we expect our initiator to be. If our initiator is an account ID on our chain, then there's no great reason why we can't just descend origin into that account ID and just do it from there. And then there at least is an origin when it arrives at the destination point. It might not be a very useful origin, but at least there is one. But now we do. All right. What are we doing here? So, this is the case where we're depositing an asset on a reserve chain, and in doing so, we want to send to some destination a notification message. Hold on a minute, let's see where this is going. Yes, right. Right, and in doing so, we want to send, we want it to send a notification onto dest to use whatever asset that is in holding, which we presume is a wrapped asset, right? One of these one-to-one fully backed derivative things. With this, and in this case, we're just depositing it in our account, okay, or in some beneficiary account actually. Yeah. So this is an instruction that gets sent to a reserve chain that says, gets sent to a reserve chain with some assets in its holding register that says, take all of the assets, deposit them in the account of the sovereign account of this guy, this location, and then send a message onwards to this location that tells it that it's got these assets, and then tells it to do this with the wrapped assets. Yeah. Now, what is received in the destination, the final destination, is this trusted notification. This is an important one. Reserve asset deposited. What it says is that a chain that you trust as being a reserve for some asset has received some of that asset. Here's the asset it's received. We see this clear origin again, because again, we can't trust, the reserve doesn't trust whoever created these instructions to act on its behalf on the destination. And similarly, it can't tell the destination, hey, it's not me, but it's this other sender, because why should the destination trust the reserve to speak for that sender? So all it can do really is clear the origin. Now, as I said before, we might maybe change this into a descend origin, which is a slightly better thing. but it's still not really super helpful, but it might be a little bit more helpful than no origin at all. Okay. Good. So we looked at the XCVM, or not all of it, right? We've taken a fairly selective look. There are some other stuff that we haven't covered, but seen a few of the instructions, seen a few of the registers. Looked a bit at re-anchoring. That's an important one. So locations are relative. If we're programmatically creating messages, then we need to re-anchor some of those locations. We've looked at cross-consensus transfers, teleports being the easy one, where there's a trust relationship between sender and receiver. Reserve transfers, where there isn't a trusted relationship between sender and receiver, and we have to go through a trusted intermediary. Trusted intermediary sounds bad, but in reality, we trust all asset issuers not to issue more assets than we expect. So as long as the intermediary is the asset issuer, we're not adding anything extra into the trust relationship. Yeah, that's why it's acceptable. And furthermore, I mean, we're definitely not talking about a person who is a trusted intermediary or like an organization that's a trusted. It's not like a bank or anything. It's still a chain. It's just that it's a chain that we trust on behalf to manage some particular asset. And we looked at a few of the instructions with a big focus on why we have clear origin, when we expect to see clear origin, and some of the instructions that we expect to see when we're doing these kind of proxy transfers or reserve transfers, right? When there's a third-party chain sitting between sender and receiver. Good. Let's hold it there for now.